So let us start with viscosity. Now, viscosity is resistance to flow. So what generally happens is, let us say that if you understand it in terms of stress and strain, if a load is being applied uh, tangentially on a body, let us say we are applying a tangential load on the body, what happens that this leads to shifting of planes one over another. Let us say by an amount phi, and this phi is called as your shear strain. And you have tau, which is called as your shear stress. So tau by Hooke's law, tau is directly proportional to phi. So tau becomes equal to g phi, where g is called as your modulus of rigidity. The same happens in the case of fluids. So in the case of fluids, what happens? Let us say that you have a system where tau is been acting here, and you have a velocity u plus du at this end, because this is sliding over the other plane. The velocity at this plane will be u, and you have a complementary shear stress of magnitude tau, because these two have to be of the same magnitude so that equilibrium is being maintained. So this we have, this is how the fluids slide plane by plane over one another. So let us say that this is one streamline of a fluid, this is another streamline, this is another streamline. So each fluid layer is actually sliding one over another so that flow is being maintained. So beneath it, there will always exist a plane which is actually not sliding, which is stagnant. Planes above it have different velocities of sliding, and the topmost layer is said to be sliding with the maximum velocity. The reason is that the forces are applied tangential, that means onto the topmost layer of the body. So Newton's law of viscosity says that, by Newton's law of viscosity, it says that tau is directly proportional to du by dy, where du is the change in velocity, dy is the distance. So to tau now becomes equal to mu du by dy, where mu is called as your viscosity. This mu viscosity is the resistance that is offered by the body. Here, if you compare, G is modulus of rigidity. Modulus of rigidity is a material property, and it tells you how rigid the body is. That means how more resistance is being offered by this body to this tangential stresses. Similarly, here mu denotes viscosity, and this viscosity means that how much more resistance the body is been offering to the other body. Now, of one planes over another. So if you look at viscosity, if you look at the system of viscosity, you can say that mu for water is less, milk is a bit more due to the fatty content, lubricating oil is a bit more, because greater the viscosity, greater will be the resistance to flow. So viscosity, if you look at the units, mu is given by tau by du by dy, where du by dy is called as your velocity gradient. Is called as your velocity gradient. So if you look at the units, mu becomes equal to tau is Newton per meter square divided by, this is meters per second, and y is again meter. So this is divided. So this is into 1 by m. So the unit of mu becomes equal to Newton per meter square. Uh, sorry, second. So Newton per meter square is Pascal. So this is equal to Pascal second, as Newton per meter square is equal to Pascal, and this is written as PA. Okay. So if you come to Poise, Poise is another unit of viscosity. So Poise is 1 gram per centimeter second. Poise is written as 1 gram per centimeter second. Somewhere it is also written as 1 dyne second per centimeter square. So in foot pound, in European countries, we follow foot pound second system. So dyne denotes what we say Newton. There it is said as dyne. Okay. So this is Poise, and if you want to write centipoise, this is another system where centipoise is 10 to the power minus 3 poise. So this is about viscosity. Okay, so this is how you represent, this is how you measure. If you talk about viscosity again, there are two types of viscosities. One is a static viscosity, and the next one is a kinematic viscosity. So if you say kinematic viscosity is measured when you have fluids always in flow. So kinematic viscosity, it is denoted by mu. This is equal to static viscosity divided by mass density. This is equal to mu by mass density. So mu of water, you need not remember this. It is 10 to the power minus 6 meter square per second. बिकॉज मास डेंसिटी है, मास पर यूनिट वॉल्यूम है, तो यहां से न्यूटन आपका कैंसिल हो जाएगा. सो इफ यू टॉक ऑफ म्यू ऑफ एयर, दिस इज 15 into 10 to the power minus 6 meter square per second. So you can say that air has more viscosity as compared to water. So it is said that kinematic viscosity of air is 15 times greater than the corresponding value of water. Okay. So this is a numerical where let us see that you have two horizontal plates. So the two plates are kept 0.15 mm apart, and it is filled with oil of viscosity 1 poise. The upper plate has an area of 1.5 meters square, and it is made to move with a velocity of 0.5 meters per second. You are required to find out the necessary force and power. So by law of viscosity, what you can say that tau is equal to mu du by dy. Okay, so mu is given as 1 poise, so which is equal to 0.1 Newton per Newton second per meter square. Newton second per meter square, and du is given as 0.5 meters per second. Okay, so if you put all the values into this formula, you have tau is equal to 0.1 multiplied by du is 0.5 meters per second divided by dy. ठीक है? So dy is 0.15 mm apart. So distance between plates, y denotes the distance. So this is 0.15. So this is 0.15 multiplied by 10 to the power minus 3. Why you are multiplying it by 10 to the power minus 3? Because you want to convert this into meter. Here all the units are in meter. This is 0.5 meters per second. Okay, this is 0.1 Newton second per meter square. So all the units have to be maintained. So if you calculate it, it comes out to be 333.3 Newton per meter square. So this is the stress produced, but you have to find out the force, the necessary force. So force is equal to tau into area. So you have 333.3 multiplied by area is 1.5 meters square. So if you multiply this, you have approximately 500 Newton force is required. The next one is power. So power is equal to force multiplied by velocity. So force is 500 and velocity is 0.5. So this gives you 250 Newton meter per second, and Newton meter per second is watt. So this is 250 watt. So this is one small numerical that I have taken to make you understand how numericals will be in this chapter. So if you see this numerical, अब एक हाइड्रोलिक रैम है 20 सेंटीमीटर डायमीटर का, ठीक है. अब उसमें रैम का मतलब होता है पिस्टन, ठीक है, जो कि एक 20.016 सिलेंडर के अंदर मूव कर रहा है. तो सिलेंडर का डायमीटर जो है वो 20.016 है, पिस्टन का डायमीटर 20 सेंटीमीटर है. इसमें तेल भरा हुआ है. इट इज फिल्ड विथ ऑयल ऑफ विस्कोसिटी 3.5 स्ट्रोक्स और डेंसिटी जो है तेल की वो 0.85 है. ट्रेवल जो करना है पिस्टन को वो 3.2 मीटर्स ट्रेवल करना है विद अ वेलोसिटी ऑफ 15 मीटर्स पर सेकंड. आपको फ्रिक्शनल रेजिस्टेंस निकालना है. सो दिस इज द प्रॉब्लम. अब इसमें यू नीड टू प्ले विद द यूनिट्स. अब अगर स्ट्रोक्स गिवन है, सो दिस इज काइनेमेटिक विस्कोसिटी. सो काइनेमेटिक विस्कोसिटी, it is denoted by mu. This is 3.5 strokes. So if it is 3.5 strokes, this is 3.5 centimeter square per second. So if you convert it into meter square, this is 3.5 into 10 to the power minus 4 meter square per second. ये -4 से क्यों मल्टीप्लाई किया? क्योंकि सेंटीमीटर स्क्वायर को मीटर स्क्वायर में कन्वर्ट करोगे तो 10 टू द पावर 2 सेंटीमीटर इज इक्वल टू 1 मीटर. तो 10 टू द पावर -4 से मल्टीप्लाई होगा तब ये मीटर स्क्वायर में कन्वर्ट हो जाएगा. अब मास डेंसिटी गिवन है, दिस इज 0.85. mass density is given as 0.85. So if you convert it into kg, this is 850 kg per meter cube. ठीक. Now dynamic viscosity is mu is equal to rho into v. So you have 850 multiplied by 3.5 into 10 to the power minus 4. So this gives you 0.2975 न्यूटन सेकंड पर मीटर स्क्वायर. वो जो हम पास्कल सेकंड में ले आ रहे थे वो अब पास्कल सेकंड में आ गए. सो यू हैव गॉट द डायनेमिक विस्कोसिटी. अब थिकनेस ऑफ ऑयल फिल्म. अब देखो ऑयल कहाँ पे होगा. इफ यू लुक एट अ पिस्टन सिलेंडर असेंबली, अगर हम ये देखें, ये आपका एक पिस्टन है, इसके अंदर एक एक सिलेंडर है और इसके अंदर एक आपका पिस्टन मूव कर रहा है. तो ये जो खाली जगह है, ये जो डिफरेंस इन डायमीटर्स है, इसी के अंदर तो ऑयल होगा. ठीक है, तो अगर इसी के अंदर ऑयल होगा, सो थिकनेस ऑफ ऑयल फिल्म कितनी हो गई? 20.016 माइनस 20 डिवाइडेड बाई 2. 2 क्यों हो रहा है? क्योंकि दोनों तरफ ऑयल है ना, थोड़ा सा इधर है थोड़ा सा इधर है. सो इन दोनों के बीच में जो थिकनेस चाहिए वही हमें चाहिए. सो दिस इज इक्वल टू 0.12348 meters. You have converted in this into meters क्योंकि ये सेंटीमीटर है, ये सेंटीमीटर है, तो 0.16 डिवाइडेड बाई 2 हो जाएगा. दिस इज सेंटीमीटर. हमने उसको 10⁻⁻² से और मल्टीप्लाई कर दिया तो ये होगा. अब आ जाओ शियर स्ट्रेस. शियर स्ट्रेस is equal to tau, this is mu du by dy. So tau can be written as mu into velocity divided by thickness of oil film. ठीक. सो म्यू आपका निकला हुआ है 0.2975. 0.2975 मल्टीप्लाइड बाई वेलोसिटी कितनी है 15 सेंटीमीटर्स पर सेकंड. सो 15 सेंटीमीटर्स पर सेकंड को अगर आप मीटर्स पर सेकंड में करोगे तो 0.15 मीटर्स पर सेकंड आ गया. डिवाइडेड बाई थिकनेस ऑफ ऑयल फिल्म कितना है 0.12348. ठीक है. सो यू हैव शियर स्ट्रेस, द फ्रिक्शनल रेजिस्टेंस इक्वल टू 557.81 Newton per meter square. Now frictional resistance is stress into area. ठीक है. तो what is the area? So frictional resistance is stress into area. तो स्ट्रेस कितना है आपका 557.81. एरिया कितना है दिस इज पाई डी एल. इसका एरिया कितना होगा पाई डी एल. पाई इंटू डी इज सर्कम्फरेंस मल्टीप्लाइड बाई लेंथ ऑफ ट्रेवल. So this is pi into 0.2 into length is 3.2. So this is equal to 1121 Newton. So this is your frictional resistance that will be offered by the fluid. Now next is Newtonian and non-Newtonian fluids. So if you look at Newtonian and non-Newtonian fluids, fluids which follow the relationship tau is equal to mu du by dy are called as Newtonian fluids. Those who they do not follow, they are called as non-Newtonian fluids. If you can see tau is equal to mu du by dy, this is a straight line relationship. So if you plot the graph between, this is stress, shear stress tau and velocity gradient du by dy. If you plot the graph between tau and du by dy, so this straight line, the fluid which follows the straight line path, it is called as Newtonian fluid. Okay. There are some fluids which follow this path. These are called as dilatant. The most common example is blood. Blood is a non-Newtonian fluid. Okay. There are fluids which follow this path. Okay. This is called as an ideal fluid. Why this is called as an ideal fluid? Because it does not provide any resistance to flow. It does not provide any resistance to flow. So this is called as an ideal fluid. So the shear stresses are 0. So this lies exactly on the x-axis. So this is called as dilatant. And if it follows this path, this is a curve. This is called as pseudoplastic. These are called as pseudoplastic fluids. So pseudoplastic fluids are uh, clay, सीमेंट. आप लोगों ने देखा होगा कि जो समुद्र, जो नदी पे जो क्ले मिट्टी होती है, ठीक है, दैट इज इन अ स्टेट ऑफ नॉट फुल्ली सॉलिड. सो दे टेंड टू फ्लो वन लेयर ओवर अनदर, सो दे आर कॉल्ड एज सूडोप्लास्टिक. क्योंकि ये फ्लो होता है तभी हम कहते हैं ना कि जब बाढ़ आती है तो फर्टाइल जमीन ऊपर से ले जाती है. तो फर्टाइल जमीन क्या है? वो क्लेई सॉइल ही तो है जो पानी के साथ बह जाता है. इस सीमेंट का इस्तेमाल आप देखो, हम इसको फ्लूइड फॉर्म में एक पूरी तरह से फ्लूइड नहीं, लेकिन सेमी सॉलिड स्टेट में हम इसका इस्तेमाल करते हैं फॉर आरसीसी, कंक्रीट बनाने के लिए. आपने एक गोल सा पेट वाली मशीन देखी होगी जो रोटेट करता है, जिसके अंदर आरसीसी का घोल तैयार होता है, एंड दैट इज मेड टू फ्लो. देयर आर machines, there are trucks which carry this RCC fluid and they make it flow from at a specified location. So this is about Newtonian and non-Newtonian fluids. So Newtonian fluids are those fluids which follow the relationship tau is equal to du by dy. ये एक straight line relationship होगी. Other fluids are called as non-Newtonian fluids.